this video, we're going to take a look at lightening all of the pixels in a picture. The Just4Pi Media Computation library provides a function for us that will do that. It's called Make Lighter. And so let's take a quick look through the code we have already written on screen. We're calling this function Lighten. We're taking an input parameter of a picture. We're iterating through all of the pixels in the picture by doing the for statement. For each pixel, we're getting its color, and then we're using the Make Lighter function to give us the lighter color. It takes an input of the color, and we got that from the line above. We get back from Make Lighter a color, so we need to assign that to a variable, and then we do the set color like we have before, changing the pixel that we have to the new color. So let's take a look at what this looks like when we run it. Let's grab a picture and let's open up JPEGs, and we'll go with Big Ben. And then we'll run the Lighten picture and let's show it. And it ends up looking like this, which doesn't look drastically different from what you might remember the Big Ben picture looking like. But let's, down here in the command window, let's go ahead and call up the original, and that we will have it to compare. So let's make the picture again, choose Big Ben, show it, we'll drag it back into the video area, and let's get the original. So there we have the two versions. On the left is the original, on the right is the lightened version. Not drastically different, but I think you can tell that the color of Big Ben is a little bit lighter. It's just a little bit lighter blue. Maybe even the white is a little bit brighter on the right than it is on the left. That's the function we have available to us. It doesn't drastically change the color, but it lightens it just a little bit. We could call the lighten function multiple times if we wanted to continuously lighten it over and over. But let's take this example code and imagine that we just want to lighten the right-hand side of the picture. So we want to leave the left the way it is, and then we want to change the right side. Imagine a vertical line down through the middle. I'm going to keep my original version of it, but I'm going to go ahead and close the lightened version that we just did. So what would we have to do to the code here that we have if we want to lighten just the right-hand side? Because the code right now is looking at every pixel and changing every pixel. Well, if we knew the X value, we could decide if it's to the left or the right of the center line. So let's come here and get the X value by doing get X of pixel. So now we've got the X value, and then we could use an if statement to say if X, remember we want to change the right-hand side, so I want to say if X is greater than get width of picture. And we're going to divide that by 2. So we get the full width of the picture, divide by 2, and we pose the question, is the X coordinate of this pixel we're looking at greater than that middle point? We need a colon. If it is, we want to get the color, make it lighter, and set it. So we only want to do those 3 things if that if statement is true. So not a big change. We introduced a new line to get the X value, another new line for the if, and we had to change our indentation. So 2 new lines and a little reformatting, and we're there. Let's see if it works. So let's load it. Let's reestablish our picture. Run our lighten function again and show it. And bringing it back into view, here is our new version. So we've got the original on the left and the lightened version on the right. So it in fact started in the middle, and anytime it was to the right of that middle line, it changed the pixel. But if we think about this program we have is having to go through and look at absolutely every pixel in the picture. But we really only want to do anything with the ones on the right side. So it's kind of a waste of time and effort to get any pixel left of this center line. Is there any way we can rewrite our code to deal with that? Well, with the structure of our for statement, the answer is no, not really. Using a for pixel in get pixels, in doing a for thing type structure, that I like to call it, we don't have any way of getting just the right-hand side without doing the conditional statement. But what if, instead of doing a for thing type for statement, we did some nested for range or for number type loops? So I'm going to come down here and let's create a new function. So we'll def, let's say, lighten right half. We'll describe what it's doing. And we're going to use picture as our input parameter again. And instead of doing for pixel in get pixels, I'm going to say for x in range, starting at 0 and ending at, we're going to go to get width of picture. Now, to begin with, let's just try changing the entire picture. Make the entire picture lighten, and then we'll see what minor change we have to make to just do the right-hand side. So then I also need a nested loop here. It's going to be for y in range 0 to get height of picture. And what do we want to do inside there? Well, we basically want to do the same thing we were doing here. We want to get its color, make it lighter, and set its color. So I'm going to go ahead and grab those lines and paste them down here. Does that duplicate what we have then? Well, actually, we don't have pixel in this code yet, do we? So we do need a way of retrieving that individual pixel. So we need to create the pixel variable by saying get pixel from the picture at the x and y coordinates that we've calculated via our for statement. And let's make that an equal sign. So we've retrieved a pixel via the get pixel function. We get the color of that pixel. We make that color lighter, and we set the pixel to that color. Let's run the code and see if it works for us. Again, this would be changing the entire picture. Oops, we have a mistake. Let's see if we can find what's wrong. So let's see what it's saying here. We've got an unmatched parenthesis. And I did that on both of the for statements. So we need another one here at the end of each one. Now let's see if it's happy. Okay. So let's get our picture again. Let's run our lighten function, which we called lighten right half. We'll give it pick. And again, remember, our function is going to lighten the entire picture at this point. We haven't made that change yet. And it's found another mistake. And that's because I typed a capital Y instead of a lowercase y. So we've corrected that, and let's try it once more. Make our picture. Run our lighten function, and let's show our picture. And there is our fully lightened picture. So what change would we have to make to this code so it only does the right-hand side? If this was the code we were starting with that we know lightens the entire picture, well, it turns out we have to change this one thing. We don't want our x value to start at 0. We want it to start halfway across, which would be get width of picture divided by 2. So we'll start at the halfway point and go to the all the way point and only generate those x values, but we do want it to generate all of the y values top to bottom, so we start it at 0. So we've made that one change. Let's load it, reselect our picture, run our lighten function again. So we got an error, and it's complaining about a float object, cannot be interpreted as an integer. So our division here, we must be working with a picture that has an odd number of pixels in the width. And so when we divided that by 2, we got half a pixel. So we can fix that one of two ways. The simplest way is simply to tell it to do integer division. And that way it'll always give us the integer portion. We could also have put an int function around that whole calculation of the get width divided by 2. But it's simpler just to do integer division. So let's see what we get now. And here is the result of our code. So the right-hand side is the original, and we have the lightened version on the right. So the flexibility of having the nested for loops allows us to, with very minimal change it from processing the entire picture to processing half the pixels. What if we wanted to just do the bottom right corner, or maybe just the top right corner? What change would we have to make? Well, if we wanted to do the bottom right, we'd be starting our y value at half the value, half the maximum value. So again, it would be changing this 0 to half of get height. If we wanted to just do the top right, we would actually still start at 0 on the y, but we could go to half the height by ending at half the height. Let's run that real quick just so we can see it. And there we go. Just the top right portion is changed because we have our x values starting in the middle and going to the right side, and our y values starting at the top and going halfway down. So we didn't touch any of the inside code. We didn't have to generate an x value, or we didn't have to look up the x value and add a conditional. It just looks at only the pixels we wanted to begin with, and therefore the program would actually run faster because it's only looking at the pixels it needs to look at, not all of them, like it would be in the first. So we looked at a variety of different options of how to modify the code. As we generated the code, we discovered that we made some common errors and how we did that debugging to figure out what we needed to make the change to make it work. So hopefully you find this helpful. As always, if you have questions, reach out to me. But otherwise, we'll see you in class.